manufacturers in the world, and being an IoT ecosystem partner, Bosch is probably one of the biggest adopters of IoT also on a global basis. And that is what I will share with you a little bit during this presentation, connecting from where I left off last year, where I already introduced some examples, and coming back to what Charles said before. This is all about proving that this is worthwhile, right? This is about efficiency, this is about productivity, this is about ROI ultimately. And I will show you some examples from around our connected world and to show you also what the benefit actually is. In concrete terms, how much productivity we gained, how much we were able to improve our error rates, for example, and how much productivity we all in the end increased. Now the good thing is, if I think back 3 years, we were still talking about what is the IoT, right? We talked about what is the IoT formula. Now, in the meantime, that's pretty clear. We have intelligent assets, and Charles is absolutely right. That doesn't mean that everything is being transferred into the back end, but there are a lot of back end services which are combined with these intelligent assets, which then together provide a lot of additional services, hopefully, and bring about these kind of benefits. Now, the good thing is that in terms of technology, the IoT infrastructure in principle is in place. We are still doing a lot of work in regard to technologies like the one mentioned before, LoRa, for example. We just launched our first sensors. They have available now parking sensors which are using that technology, significantly improving the way how we can transmit data, do it over long periods of time, leave these devices out there, isolated in the cities actually, without having to replace them on a continuous basis and still being able to kind of get that data from them and work with that data on an ongoing basis, right? Now, a lot of companies, and some of them are listed on here, have made significant bets on the IoT, right? And we know all about Nest, we know about the kind of services Tesla is offering, the kind of services also Uber is offering, and that is certainly very exciting. Manufacturers, for example, on the other side have taken a little bit more balanced approach, which is good and which provides a good balance between investment and risk, hopefully. But nevertheless, we see that everywhere IoT is on the executive agenda. That's probably why a lot of you are also out here today. Now, we have done this since a long time. I just want to show this in order to put into perspective what we are doing also here in Asia Pacific, and a lot of the examples I'm going to show you later on, they originated here from Asia. We have our hub in Singapore. We are using Singapore as our development center in this part of the world, and we find that this is a very successful model, while we are actually doing a lot of deployments now in the meantime from Australia up to China and Japan ultimately. Now, IoT is a very important topic at Bosch, and the ones who have been around the last 2 years will know this already. I've been talking about this for a while now. We are working into 4 sectors in principle. We are talking about connected manufacturing, what some of you are also known under Industry 4.0, and the minister mentioned it this morning. The 4th generation of manufacturing is about us, and we are seeing, as I said, later on some of the benefits which we are already having revealed in our own kind of plants there around the world. We are also working into connected energy, a very important topic. It was also mentioned by the mayor of Eindhoven actually earlier today, being a very important aspect of city infrastructures, and we see a revolution also on the energy side, going away from more central kind of approaches in terms of power generation to decentral ones. We are seeing it here in Singapore with panels coming up on all the HDB blocks ultimately, and we have to find ways of how we are improving the way how we not only generate the energy, but also then how to use it and bring it to the right places at the right points in time. Classical and fantastic use case for IoT. And then obviously we have things like transportation. Cars are a very important part of these things which are around us and which are already IoT enabled to a large extent. 6,000 to 8,000 sensors, as mentioned before, in high-end cars. 70 ECUs in a car of that sort. That means 70 computers being in there, which are then processing a lot of that data within the car, but also working with intelligent backends. And I will show you 2 examples of that later on also, how this works and what the benefits for you as a driver ultimately will be in doing this. And then another aspect, connected buildings and cities. Also, there's some examples. Now, let's go to the examples, because that's the most interesting, right? What are we doing with all this kind of technology ultimately? And the first one, put yourself into a car, right? I just mentioned I will have one or two examples about cars also. Put yourself into a car, driving along the coast, let's say in Italy or in California, beautiful areas actually. You're driving along, you're watching the scenery on the right side, and you're just coasting along, right? Now, there's a lot of stuff happening in the background. You remember that picture from before with the iceberg, 10% on top, 90% on the bottom. There's a lot of stuff happening in the background there, right? And one of the things which is happening, which will be happening in the near future, is that we will aggregate information outside of the car and provide that into the car at the right point in time. For example, in this scenario, you drive along the road, there might be a temporary speed limit somewhere a mile further down the road, actually, right? Now, you're coasting, right? You're not trying to win a race here. You're coasting, right? And that means we can actually then use that information to switch off the motor. Some of you might know your start-stop automatic in the car, right? Which already today, when you stop the car, switches off the motor and so on. There's something which is called sailing mode. Nothing to do with wind and stuff like that. It just means that ultimately we have the ability to switch off the motor, the engine in the car, and to then actually coast along and bring the car naturally down without using the brakes or anything like that. Bring it naturally down to the right kind of speed a mile down the road, right? You don't have to do anything. You're still watching the scenery on the side, right? Perfect. This increases efficiency. This reduces CO2 emissions. It reduces actually gasoline consumption. Perfect example. You will see that very soon in your cars actually happening, right? Very concrete example. Use IoT technology in the background. You will not know anything about that, right? It comes out of the cloud. It just happens, right? Okay? Another exciting example, also happening already right now. We call it digital twins. The ones which are familiar with IoT technology are probably familiar with this term. It just basically means that we sandbox information, right? Sandbox information in the cloud. We provide all the information actually, which is coming out from these 6,000 to 8,000 sensors, for example, in the car. We provide this into a cloud environment. And from there, applications can easily pick up this information, can work with that information, can work with that data. Create exciting new examples of usage like I just shown, without having to actually worry about how does this actually get into the car? How does my information comes from the car and goes back into that? That's a lot of effort actually, right? If you would start from scratch, you would have to think about hardware, you would have to think about SIM cards and all this kind of stuff, right? Which is representing 20% of the cost, as we had heard before. All of that goes away, right? You're working in a sandbox environment somewhere in the cloud. You develop your app, and that's it, right? All the rest is happening automatically. It's taken care of by that digital twin in the cloud ultimately. That is improving how we can do and how we develop apps, for example, probably reducing costs by up to 90%, right? We are in our own kind of development environments are seeing that this can reduce costs really by up to 90%, right? A factor of 10, ultimately, in terms of cost. Instead of paying 100, you pay only 10. So this is very, very important. And of course, that is also addressing a key issue which we have heard before. You remember security, right? We don't want to have actually all kinds of app developers necessarily intervening with what is happening in the car, right? We want to have a layer in between there where we can make sure that these things do work ultimately, and that we are not affecting security, safety relevant kind of issues, which are of course going on in a vehicle, right? Now another example of a digital twin. This is from a conference which we organized, and we have one of the conference organizers here with us today, Dirk from Germany. We had our Bosch Connected World. We brought about 1,000 ecosystem participants together in Berlin actually this time, and they were actually discussing about the state of IoT, how we can further develop this, etc. This included companies like GE, PTC, so not a Bosch conference, actually it was really an open conference, and we used this actually here as an example, right? And this is a digital twin, there was a digital twin, so to say, of the conference center, the Berlin Congress Center in the cloud, and we did a mashup actually between the Bosch IoT Cloud and the digital twin available in that cloud about this environment in the Berlin Congress Center and Spotify. So scenario, just imagine yourself, in the evening you're coming home, your car is approaching your home, it's at a certain time of the day, you might be in a certain mood actually, right? Your smart home system at home receives a message, actually receives an indication that you're 10 minutes away actually, right? That in a certain mood at this time of the day, and that ultimately you want to maybe hear a certain type of music, right? So the system can then automatically pull a certain stream from Spotify and play it while you're arriving at home actually, right? Very simple kind of scenario, but it just shows the possibilities, right? When you start to mash up all these services in the cloud, this becomes very elegant, very easy actually to aggregate new services, develop new business models ultimately with that, right? So just a very simple example here, but the possibilities behind that are nearly limitless actually, right? Just imagine what would be possible doing that, right? Or is possible, not what would be possible. This is not a would be anymore, this is an is, right? Connected parking, I mentioned these connected parking sensors, right, before. About that size, using LoRa technology, 7 years of battery life in there with a coin-sized battery, 13 kilometers of data transmission wireless over the air. Fantastic stuff actually, right? You can just embed it into the street somewhere, you can forget about it, and it will actually provide you the data over long periods of time, right? No need anymore to change all of that on a continuous basis. This is in a scenario which we call social IT. Social IT basically relies not only on these sensors embedded in the street, but it relies on sensors which are driving around in our environment, because we have heard every car has a lot of actually sensors embedded into it anyhow, right? Why don't we use these to create a digital twin, so to say, of our environment, of our whole city actually, in the cloud? So how it works is you have these kind of ultrasonic sensors in your car, right, for parking, which tell you that you're too close to the wall or to your neighbor in front. And these parking sensors can be used to scan your environment while you're driving along a road. Now, why is it important that this is social, so to say? Because it's crowdsourcing of information, right? The more assets we have out there which are scanning our environment, the better information we ultimately get. We aggregate the information from thousands of cars, and why this also has to be social is it should cross from manufacturer to manufacturer. It should not be only available to, let's say, BMW drivers. Nothing against BMW drivers, but it should be available also to the Toyota drivers of this world, to Volkswagen. It should be actually aggregating the highest amount of information out there in order to get the highest amount of accuracy, right? So aggregate all that information from all kinds of cars around the city, correlate it with map data, make sure that you actually have a legal parking space in front of you and not an exit of a condominium or so, and then provide that back into the navigation systems of the car in order to bring you to the closest parking space possible. Reduces the amount of driving around aimlessly in a city for parking space tremendously. Now let me illustrate that in a little video myself actually, one movie actually, right? One movie. Good, community-based parking, certainly an interesting application and part of a potentially larger smart city environment, right? Who recognizes the city there? Who knows the city? Who has been there? You have, right? This is Berlin, by the way, right? That is where we had our conference there recently. You see the radio tower there, the TV tower. That's the center of one of the centers of Berlin, the Alexanderplatz. On the left side, you see the cranes. That is where they're rebuilding the old castle of Berlin. Amazing city. Please be invited to go there. It's a fantastic place, but do me a favor, when we had the Bosch Connected World Conference there 3 weeks ago, maybe not the best time of the year. Go a little bit later, actually, when it's summer and a little bit warmer. But why I'm bringing up that over there, this picture is, there are a lot of other use cases, right? Connected parking is obviously one of them. I mentioned before already energy-related use cases, which are here expressed as virtual power plant, which we are doing. in various parts, for example, in China these days. We are also talking about something which is called a citizen app. And it was a very interesting presentation which I wanted to briefly talk about at this conference also, from a developer called Glenna. They're one of the largest property developers in the US. They're at the moment in charge of redeveloping the shipyard area in San Francisco. Maybe some of you might know this area. It has been neglected for many years. It was more or less abandoned, actually, right? It will now be rebuilt, revived. There will be tens of thousands of new homes, actually, and offices and so on coming up over the next couple of years. And we're working very closely with this developer, Lena, actually, over there, in order to develop specific IoT use cases for this new environment. Very exciting because it's a green field, right? There's nothing there at the moment, a part of old buildings and stuff like that, which will be torn down. But it's really a green field, and we are developing this new kind of applications, one of them being the citizen app, right? And I think that is something every city should have. It's a single point of contact, it's a single point of relationship, so to say, for your citizens actually with the city, with the community actually at large, which then concentrates a lot of the information about, for example, traffic situation, coming back to what I just said before, about any kind of services which might be on offer, any kind of environmental conditions which might be present at that point in time, and so on, right? So what I think Charles also mentioned before, he would like to know the PMI actually in his immediate vicinity. That would be part of that, right? Air quality monitoring, all these kind of things ultimately being concentrated in there, maybe combined also, and that's another exciting area, which I believe also was mentioned already this morning, is gamification, right? And that is something we are exploring also with a number of cities, is how do you get actually to be this content to be as sticky as possible by basically incentivizing people to stay on longer, to have fun with it, to actually interact with these kind of systems in a much more natural way. And if I look my 11-year-old son, that's probably the way to go, right? Anything which is on the iPhone actually, which allows some kind of gaming content and stuff like that, he will be very excited about, right? And then there are a lot of other very exciting use cases here. Intermodal transportation, also something we are looking at in this context, as well as, for example, electric vehicle charging, something which is happening here in Singapore and has been active since about 5 years now. And we are now moving into the next phase of electric vehicle car sharing also, right? That should be probably available sometime next year here. Good. Now, let's go a little bit outside of the city, right? Because not everything is about the city. Yes, we heard that 65% of the global GDP will be dominated by 600 cities earlier today. But still, we all need to eat, right? Don't we? I guess we do, right? This will not take away the need to provide food to everybody. And so we are also talking about agriculture, and it's a fantastic use case for IoT. I think we heard a little bit about it this morning very briefly, but would like to expand a little bit on it. Because at the moment, agriculture is probably still in the phase of what we call 1.0 here. I don't know who is coming up with all these release numbers there, but somebody is saying agriculture at the moment is in the 1.0 area. Okay, fine. But if we look at it, there's a lot of stuff out there which we can improve on the agricultural side by using sensors, by using data actually, right? And in this example, this is from Europe. This is an asparagus field, and I will give you an example about an Asian context in a moment also. This is about asparagus fields, and asparagus farmers have one specific problem. They need to maintain actually the temperature of their asparagus plants at an optimal level. And that optimal level is 20 degrees, right? They will ripen very nicely when it's 20 degrees. And so what they do, they actually use plastic foil covers in order to ensure that when it's getting too cold, that they are being nicely protected and so on and can mature. Now, obviously, you can monitor that very, very easily, right? You can monitor with temperature sensors and so on what is going on in that specific area, actually, and you can then make recommendations to the growers when they should actually put the foil covers on there, right? So that you can basically then predict how the asparagus is then ripening, so to say, right? Very exciting example. By the way, also uses Bosch sensors in this context, but that's not so important because in this context, for example, we're using sensors from somebody else. Actually, it doesn't really matter. Here we are monitoring not temperature. Here we are monitoring salinity levels in water. Why is that important? Who likes oysters in the room? Okay. then a lot of soil from the land is being washed into the water. And in Australia, for example, specifically where this is running right now, the authorities actually shut down oyster farms as soon as it starts to rain, because they're afraid that the toxins which are included in the soil will be washed into the oysters and they will become actually toxic. Now, they are using weather data from miles and miles and miles away, actually, right? And if you know how much actually a farmer on an average day produces, it's about $100,000 worth of produce, they will lose that immediately and cannot recover that, right? If they if they have to shut down the farms, they will lose that produce actually, right? Most likely. And so there's a tremendous impact, about $34 million annually in Australia alone of oysters which are lost, right? For consumption because of oyster farms getting shut down based on data which is actually not accurate, right? Because it's weather data which the authorities use, which is very coarse and probably from areas which are not very related to what is happening locally. So what has happened actually, the yield, which is the service provider in this context, there's a bunch of agronomists and technologists actually, they have come up with a system which we have helped them to implement, which actually looks at a salinity level in that specific area next to the oysters, right? And that actually allows them to tell the authorities exactly what the condition at this point in time is, and actually tells them whether they can produce or not produce. There's another aspect of that also, and that's productivity. We heard before about productivity being important. So labor actually is a very important cost component for oyster farms. And when they cannot produce, they basically have people sitting around, right? So what they can do actually with that information, they can schedule their production staff a lot better, their production crews, can send them to other areas probably, etc. And they have found 25% productivity improvement actually through this approach, right? Fantastic use case. This is now being rolled out on a larger basis. There are some challenges at the moment the Australian oyster industry has. There's a certain disease going around which has to do with water conditions. They're going to use that approach in a large number of farms in Australia in order to improve the situation actually, and to make sure that all of you who like oysters have something really safe and really nice to eat actually, okay? Good. Now, so much for agriculture. Let's come to something which is very close to our heart, right? As I said, Bosch is one of the largest manufacturers of things in the world. And so IoT for us is a very important kind of consideration when we are looking at our own operations, right? Think back, operational efficiency and so on, right? This is what people think about. And these are things which we are doing in our own plants, right? As well as this being available for others too. So we are basically connecting machinery. We're using that data to improve the outcome. In this context, for example, monitoring the error rates of certain kind of tightening processes, for example, here. We have seen improvements of 10% on the error rate and certain other improvements here too in terms of productivity. This is something we are now doing across the whole world actually, right? We have similar installations of this kind of stuff in Korea, in China, and India. We are now doing this, not only for us, but also for our clients. And so this is a very practical example. This is something which you can implement now within a day, actually, or two, right? So the recent installation we did in India took 1.5 days, right, to do this for a plant, right? Fairly straightforward, actually, fairly productized by now, and not so difficult anymore as it would have been maybe 2-3 years ago when we started with that kind of journey. Now, this is something we have also done on a much larger scale. And this is, for example, from Homburg in Germany. This is a production line which I think was already mentioned last year, but it's very, very interesting. And now we have the results from that undertaking. This is a production line which produces a high number of variants. And for the ones who are familiar with manufacturing, that's a killer, right? Variance actually makes it really, really hard to work on your productivity and efficiency. We have, for example, 2,000 raw components going into this production line. They're producing 200 different variants of hydraulics on the same production line, right? So the lot size here is really one. They're producing individual pieces to different specifications all the time, right? So lot size one, very, very hard to achieve. This is a completely Industry 4.0 enabled manufacturing line. You see the results over here. We got a 10% output increase by doing that. We got a reduction in stock keeping, and we are saving €500,000 a year actually by doing this, by connecting the manufacturing line, by getting more data actually, by providing better data actually to the operators there also, by helping them to go along, providing up-to-date information about what they have to do, how they have to do it, and so on, right? Fully automated actually the whole thing in terms of the data gathering and the data provision, and a very, very good example actually, and that is probably a large part of the manufacturing of the future, right? We heard about this morning, the plants of the future and so on, what they're also trying to do here in Singapore. Lot size 1 is, so to say, the holy grail, where you want to go to, because that will allow you ultimately to go to decentral kind of manufacturing and all this kind of stuff. That is what is behind it ultimately, right? Now let's take this into a larger context. Let's take that into an international production network, right? So that means an aggregation of plants which are working together on a global scale to produce large number of devices. So that's the opposite, right? That's now mass manufacturing, right? Exactly the opposite of what I said before. So we have these 11 plants producing 26 million units of ABS and ESP components which go into cars. And in that we have now connected about 5,000 machines. This is growing on a daily basis actually. We are still in the process of doing this. And we have seen a 25% productivity increase, right? So output has actually improved significantly by doing this, by IoT enabling that kind of international production network, right? There are a lot of components actually which went into that. There are a lot of different IoT type of approaches in there, but them all together actually, that is what we got, right? Very important result, very exciting for us obviously. And we are having on a biannual basis a big manufacturing conference. It will be this year in Suzhou in China, and this will be one of the key discussion items there. How can we now carry this into all of our plants worldwide? And I just want to leave you as a last example actually with a little example from Suzhou in China, where exactly that will be held. We are at the moment implementing a holistic production planning system over there. And why is that Industry 4.0? Production planning has been around for a long time, right? What is so new about this? Well, to be honest, in the past, we have used insufficient or incomplete information, right? We had data pools sitting around our plants in the ERP system, on the machine side, of course, in the MES systems, in the supermarket systems, and so on and so on. You can continue that actually. You had 10, 15, 20 systems. Not to talk about the individual machines, of course, right? What we are now doing, actually, we are pulling all this data together. We are aggregating all this data. We are with that eliminating the Kanban systems which have been around there before, which were fairly manually driven. And we are doing that in order to optimize the lot formation, the sequence planning, and so on, utilizing really real-time information from the machines together with the information from the stocks, actually from the supermarket systems and everything else, to do optimal kind of scheduling in the plant on a real-time basis, right? Very exciting approach. This will become a product later on this year. We're going to launch this also into the market for other people to use ultimately, and that is certainly something which we find is very, very interesting because very comprehensive, right? It really allows you now to pull together stuff from a lot of disparate kind of areas and to make it work together. By the way, I spoke a lot of about the cloud before. That should not take away from the fact that we'll still have a lot of on-premise deployments. This, for example, is an on-premise deployment for various reasons actually. And so both is possible, right? This is not about religion in a way. This is about what is practical and what is pragmatic actually in the respective context, right? Okay, now still, this leaves us with a couple of challenges which we need to address further on in order to make the IoT successful, to overcome various hurdles which are still around. Now, what are these hurdles? I think there are 3 of them actually, right? One of the hurdles is flexibility. IoT business models by definition tend to be a little bit unpredictable. We don't know about the results up front necessarily. We don't know how successful these will be in the immediate future, right? That is one aspect of what we need. The second is, of course, that we have a significant amount of variability during the day. Just think about people coming home in the evening, right? Suddenly switching on power, switching on things at home, suddenly there's a peak which needs to be regulated somehow, right? The same is true for traffic, so energy, traffic, appliances, and so on. All kinds of things, right? You will see peaks and troughs during the day, actually, significant, right? That requires elasticity. It requires flexibility in terms of how much infrastructure do we have. And we heard before, infrastructure is still rather expensive if you have to deploy it on a dedicated basis, actually, right? So that's one aspect. The other aspect is open ecosystem. We need to work with a lot of different people, right? This is not something anybody can do on its own. We need sensors, we need software, we need services, we need system integrators, we need other parties, suppliers which need to be integrated in a production network, in a value network, and so on, right? All of these need to somehow communicate with one another. We need protocols on different levels to be interconnected. We need people to be able to talk to one another. And we need to also have marketplaces which go across a lot of different domains. Remember the example about the Spotify kind of mashup there, which we did, right? Crossing domains from one domain into another, from the building into the music industry and stuff like that, right? From the car into the building and so on, right? All kinds of domain crossings which have to happen there, border crossings, right? That's the second challenge. And the third challenge, I don't think I have to explain that much anymore. It was already explained. A lot of people are still very worried about the security of their data, privacy of their data, right? It's not only about business industrial data, this is also about very personal data potentially, right? And so all of that needs to be ensured. We need a lot of technology for doing that, yes, of course, but we also need trust. And trust is built ultimately on policies and so on, right? So this needs to be ensured. We need to make sure that we have the right policies in place, the right technology in place, etc., in order to have that kind of trust in us, into suppliers in general, in order to be able for people to put their data there, right? Now, how do we react to that? What do we do? Now, we have decided that we are going to, in addition to the tool set which we have, that we also launch our own cloud. Now, you could argue, well, there are a lot of clouds out there. Why do we do this? Yes, correct, there are a lot of clouds out there which are used for specific purposes. On the other side, we have specifically decided, in order to address the concern of privacy and data security, and be able to guarantee what is happening for us, ourselves actually, as well as for other people actually which might be using it, that there is a space actually for an offering where we are going to take this to another level actually, so to say. And for the ones who might know that, Germany is probably the country in the world with the highest and the strongest data privacy laws in the world. We have decided to launch our initial cloud from Germany. The second one is now currently being built here in Singapore, because we see in Singapore a distinct level also and attention to privacy, safety, and security of data. And so we will actually put this cloud specifically into areas where we are going to be sure that the privacy, security, and so on can be ensured ultimately, okay? So that is an additional offering from us to ourselves. Obviously, we are going to use this, but we are also going to make this available to the general public actually starting next year. And for anybody who has a data privacy, data security, sensitive kind of application, please come to talk to us. We are very happy to actually also make this available, as I said, to others. Our business partners are already using that. Good, don't want to talk too much about that. Obviously, this is then being used also to provide vertical solutions in the fields I mentioned before. If you want to know about industrial IoT and Industry 4.0 and so on, there is another keynote actually in the industrial IoT stream later on by my colleague Swaroop, and he will give you a lot more detail about that, and you can ask him a lot of questions there also in terms of how it really works in a factory setting, for example. Okay? Good. Now, another aspect, the open ecosystem. Just want to quickly cover on that. We are driving an open source initiative called Vorto. Any manufacturer here in the room of things, anybody who is involved with IoT platforms and so on, I would welcome the discussion with us. This is something we are actively driving. It's about standardizing how you actually access devices, about information models, and how you quickly, as a developer then, can integrate these into your own platforms, into your own solutions. So this is very powerful. It's hosted by the Eclipse Foundation. You will find it under that address. Have a look at it. Talk to us. We are very keen. We have already large platform manufacturers like ThingWorx, for example, also on there. and we certainly would like to build that ecosystem together with you to the maximum possible. Okay? And lastly, as I have to also talk a little bit about the sensors, right? They're an important component of the IoT ecosystem. This is an XDK. This is a sensor platform. It contains all these sensors on the right-hand side. Have a look at the XDK development community over there. It's a fantastic tool for prototyping. Very easy. It's industrial strength though, right? So this is something we are now using, for example, in lifts in Singapore. Has been actively deployed here in this part of the world and elsewhere, obviously, in order to, for example, monitor lift movements and stuff like that. Industrial strength, fantastic combination of different sensors. Very easy to use, actually, in terms of getting that into your respective ecosystems there also. Something to consider, and please, as I said, talk to us if you're interested to use this. With that, I would like to conclude the presentation. Remember the 3 S's actually there: sensors, software, and services. This is something we are really living. We are probably one of the only companies in the world which is involved on all 3 levels. Very happy actually to work also with you to cross these kind of domains, as I mentioned before. And there's really not much which should hold you up anymore. We have now connected 5 million assets into IoT kind of environments. We have about 150 projects running. As I said, we are probably one of the largest proponents of IoT projects in the world at this point in time, and we will by the end of this year have about 50 solutions running in our Bosch IoT Cloud. So please do the same thing like the mayor said this morning: experimentation, right? It's all about experimentation. Try it out for yourself. See how it can apply into your context. It is not difficult anymore. We have a lot of hackathons. We had a hackathon in parallel to the Bosch Connected World, the Bosch Connected Experience, where people work with that XDK actually, and mashed up and hacked up a lot of different kind of solutions and applications in literally 1.5 days, right? This is something which is not complicated anymore. It's not rocket science. It can be done very easily. And please be invited to do that with us together also. Thank you very much for your attention. And any kind of questions, there's my address. Thank you.